Hi again, guys. And this looks like a deja vu because this problem is the same drawing that we just solved, but they are asking for different things. In the previous problem, we had this value and they were asking for the force. Now we have the force and they are asking for this value. So guess what? We have to work it backwards, but it's the same thing. So in order to simplify this problem, let me do this. This distance here is d, and this distance here is 3, half of this, right? 3, meaning the length, overall length of the spring is going to be square root of d squared plus 3 squared. That's that. And the constant is the same constant. That's why we could do the symmetric thing that we did here. This value is 175 Newton. And as of now, it looks something that we don't know any solution because look what happens here. We don't know this value, we don't know this value. Fortunately, these two are the same force, but our two unknowns are T and D in reality, or the angle. So it looks like a mess when you start looking at that. But remember, what do you have? We have summation of forces in x equals 0. And if I do summation of forces in x equals 0, what do you get? You get negative 175 plus t plus t, but it's going to be cosine of this angle. Now the cosine, the component, for this case, the horizontal component for this case, these and these are the same. So I'm going to put 2 times t, that force, but the cosine of this angle will be the adjacent, which is d, divided by the hypotenuse, which is this one. So I put that inside this equation, d divided by t squared plus 3 squared, square root of that, equals 0. Now we can work this problem out and simplify it a little bit more. And it's just this part here we can simplify and pass this to the other side. So then I will have t multiplied by d divided by square root of d squared plus 3 squared. It's going to be equal, when I pass this to the other side, it's going to be 175 positive divided by 2. That's going to be 87.5. And this is one equation. So I need another equation that relates T and D. But fortunately, we have it. You haven't realized that we have it, but we have it. Because you remember force equals, for the spring, K times X. And X is what? The stretching of the spring. We know the unstretched length of that spring, 3 meters. And we know from our diagram the overall stretch length at this point in time. And that stretching length is this. So that x, the unstretched length, will be the stretch, not the unstretched. The stretching of the spring will be the stretched distance minus the unstretched distance. So x is equal to, x will be equal to square root of d squared plus 3 squared minus 3. And this F, of course, is referring to the tension of the spring. So in other words, the tension of the spring is going to be equal to the constant, which is 500, multiplied by the stretching of the spring, d squared plus 3 squared. Minus 3, I'm sorry. Minus 3. So I'm going to copy it here again. 500 multiplied by square root of d squared plus 3 squared minus 3. Correct. That's going to be the other equation that we have. Now you see, as you can see here, we have basically a problem involving two unknowns, T and D, two equations. So if we can't solve these, it's only due to our lack of ability to solve that, because we could solve that. I'm not gonna say super easy, but fairly easy, I would say. So how do we do that? We're going to combine these two equations. Either I solve for t here and I plug it into here, or I already have this solved. I'm going to get everything that is t and I'm going to put it there and see what happens. Then what do we get? We get 500 times this. That's going to be the value for t. That's t. We continue, multiply by d divided by square root of d squared plus 3 squared. That's that. And that has to be equal to 87.5, but I'm going to pass this 87.5 to the other side of the equation, so I get a beautiful zero in this part, which hopefully is not what you're going to get in the exam if you get this problem. Okay, now how do we solve this? There you go. There's only one unknown. You can work this out trigonometrically or do whatever you want to do, and it's going to take eons for you to do that. Or you can always use our faithful trial and error method. What are we going to do? We're going to start assuming values for d and calculating if the equation converges into zero. So if I have the correct value for d, this equation should be zero because that's what we got over there. So let's try to code this equation first of all, and this is the part that is really important. So remember, parentheses are extremely important when you do this. I'm going to assume a first value for d of 1. And if this is the correct value, I should get 0. So let's see what happened here. I'm going to put this equation, 500 multiplied by parentheses, but square root is another parenthesis. I'm going to put here 1.0 as 0, 0, let's say, as my first value for d square, plus 3 square, I'm going to put 9, close the first parenthesis of the square root, elevated to the 0.5, minus 3, close parenthesis, times, open a new parenthesis, d 1.00 for the first trial, d divided by parenthesis for the square root, 1.00 squared plus 3 squared is 9, close the parenthesis to the square root, elevated to the 0.5, I already have the square root, close the other parenthesis, minus 87.5. So if we got 0 here, that will be the value, but it's not the value. So for d equals 1, we get negative 61.84. What happens if we put d equals 2 here? This is easy because I just have to go back. The equation is already there, and everywhere where I had 1.00, I'm going to put 2.00, which are 3 places. And you have to be sure that you are covering all 3 places. Oh, by the way, look, I just realized I made an error here. You see here, it was minus 3. You see what I did here? Oh, no, I put minus 3, correct. So it's not error there. So even when I think I made a mistake, I'm correct. Look how awesome I am. So 2, keep going, minus 3, that's correct. This is the other d that we have to change for 2. And then the other one is in the denominator here for 2. And the rest, I'm just going to go by to see. That's perfect. Now we got 80. For 2, we go 80.45. You see what happened here? Our solution is in between these two. The logical thing to do is just go to the middle, because If you do a quick interpolation, I know it's not going to be exactly to the middle, but we can try the middle. So we have the value for 1 here, we have the value for 2 here, and then you start with negative 61.84, and for 2 we have 80.45, meaning between these two values, between 1 and 2, we're going to have a zero crossing, and this is what I'm looking for actually, that zero crossing. This is the value that is going to make this equation to converge in zero, because that's the result of the equation there. So let's try 1.5, 1.5, and what do? We go back, same thing, and then we change everything, and everywhere that we have 2.00, I'm going to put 1. Look, I don't like doing it like that, but let's do it now because I'm here. Let's put here 1.5, 1.5, and I have to change the first one before I forget, which is 1.5. Enter. And now we get -8, -8. So for 1.5, we want the value of -8.3. What does that mean? That means that our zero crossing, 1.5 was here, -8, this is 1.5, and it's going to be really close to 1.5, really close to 1.5. So I'm going to try 1.55 and see what value we got. 1.55. So go up again, hit enter, and start changing everywhere that we put 1.5. I'm gonna put 1.55. I say right, 55, 1.55, 1.55. Enter, and now we got -1.03. -1.03. That means that it's still between 155 and 2. Let's try 1.57 for D. 1.57 and see how much we get. So what do? We go up again, and everything that we have, wherever we have 1.55, we're gonna put 1.57, 1.57, and 1.57, the 3 places, and we have to change in the equation. Hit enter, and then we get 1.98. Now look what happened. Our value is between 1.55 negative and 1.57 positive. So we can try with 1.56 or just say it, but I'm going to try with 1.56 because it doesn't take too much time. I know you have pressure in the exam and you think that you're not getting it, but just take a deep breath. I mean, don't be scared. Forget about your fears. 156. D equals 1.56, then I get 0.47. What does that mean? That my number is going to be between 1.55 and 1.56. If you want to keep making it closer and closer and closer, you can try 1.555. But hey, I can live with that. So the value for D is going to be 1.56 meters, or depending on what the problem is asking you, you could have saved time and say 1.6 meters, and that's it, and that will be the answer, with a certain margin of error, of course. Once again, the problem is not difficult. Establishing the equations, it was fairly easy, and solving, it just takes attention to detail. That's what it is, and be calm. That's what you need to be. You need to be calm. I always say this in other videos, but students always have fear, and fear is something that really you don't know. I mean, the danger is real, but the outcome is not. So fear, you can translate this as false expectations appearing real. You are already thinking that you fail, and then you start getting crazy. And the time, and look at the time. Trust me, I've been there and done that until I learn better. See you next time, guys. Have a good day.